Hi, everyone. I'm Kelly, and I'm a product director in Google Labs. Today, I'm excited to share how we're using large language models to build coding agents. So, if you're interested in learning how AI is unlocking the ability to get your coding work, and in this case, specifically your data analysis work, done faster, this is the session for you. So, when I say agents, I mean programs powered by AI that, when given an objective, are able to iteratively plan and act until their objective is reached. We here at Google believe that these agents will significantly augment developer workflows. They're going to help developers prototype, iterate, and build products and applications way faster. In some cases, these agents will work independently, that is, in parallel with the developer on asynchronous tasks. And then in other cases, the agent will play more of a collaborative role, interacting directly in a synchronous back and forth with the developer. One of my teams at Google Labs is focused squarely on building AI tools for developers. And they're building an LLM-powered dev tools platform that supports the capabilities you'll hear about from me today. I'll show you the first agent they built and give you a behind-the-scenes look at how it helps data scientists perform data visualization tasks. One of the reasons we built this is because we want to empower data scientists to explore, visualize, and derive insights from data faster. And they can do that with the capabilities of Google's LLMs. Before I dive into the demo, let's take a look at some of the features. They're pretty powerful. So first up, this agent has the capability to reason and plan multiple steps in order to perform data wrangling, data exploration, data visualization, and even some statistical analysis. It leverages Google's latest LLMs and capitalizes on Google's most up-to-date data sets and capabilities, and will continue to do so as our models evolve, including with multimodal capabilities. Second, which is very exciting for us, we're building it directly into Google Colab. You may already be familiar with Colab. It's a Jupyter notebook editor used by millions of data scientists, and it's really perfect for data exploration and for prototyping. We know from our own experience that switching between tools can cause a lot of overhead and interrupts your workflow. Minimizing switching costs helps keep developers and data scientists focused and on task, which is important to us. So because these agents exist within the tools themselves, you don't have to learn any new tricks for working with AI. You can simply use the tool you know and love for data exploration, Colab. And then third, another benefit of having this agent built directly into Colab is that it can leverage Colab's execution engine to run the code, which means that it's truly operating like a pair programmer, able to write and execute code to make sure it works before saving it to the notebook. Then it can answer more questions and do data visualizations and build plots all inside of a Colab notebook. All right, let's get into it. I'm going to show you a coding agent we've been working on that performs a series of tests to demonstrate the agent's capabilities. Let's hop over there. So first, let me orient you. We're looking at the Colab interface here. I'll give you a quick tour of it and explain some of its benefits. Colab, as I mentioned before, is a notebook that is used by millions of data scientists. What you see on the left over here is the notebook itself, and you'll see that my notebook is already populated with these gray boxes here. Each of those gray boxes is called a cell, and then each cell contains code that can be run independently of other cells. So imagine you have a notebook that has dozens of cells. With Colab notebooks, you can decide to run a very specific piece of code inside a particular cell. And this really lets you prototype and test your code a lot faster. All right, on to the demo. So for this demo, I'm using data from Data Commons that has already been imported into my Colab notebook. Data Commons, you may know, is an initiative from Google to synthesize in a single graph data from many different public sources. And the data set that I imported contains data about solar panel installations, median income per household, and rainfall in the US. Since this is my first time interacting with the data set, my objective is just to understand it at first. So let's use the agent to explore this data set faster and identify some potential correlations. To do that, I need to give the model some guidelines that are precise enough so the model executes what I have in mind. Let me paste in my question here so you don't have to watch me type. Knowing how to ask the right question is extremely important. Am I right, data scientists out there? Okay, cheesy jokes aside, I enter this question and let's see what our agent does. So the agent is going to start to walk me through its thought process at the same time that it creates new cells in my notebook, which shows its work. When a new cell is created, it's executed automatically in the Colab environment. Let's see. So I asked about the relationships between solar panel installations, rainfall, income, and build land coverage. And now it looks like the agent has identified some missing values here in the data set. So it's cleaning the data first by removing them before performing any analysis. Those are the two cells that you see it created over on the left. And it's writing the correct Python code to remove the missing values and then recheck the remaining data points. And you can see here that now our agent is starting to identify outliers, and it's using the standard deviation method to identify those outliers. Let's see what it said. Okay, this is a very polite agent. It has asked for my permission to remove the outliers. I think that's okay. So I'm going to click yes, remove the outliers. So what just happened? The agent asked for confirmation because it considers this data transformation an important one. It's going to show its work in the Colab notebook so you can see exactly what's happening and make edits to the code in the cell if you want to. And in this demo, we're using Pandas, which is a popular open source Python package for data science, data engineering, analytics, and machine learning. Here, the agent is telling me that Pandas has a built-in function that can be used to compute correlation, but it doesn't return an actual heat map. So the model is telling me it's actually going to help visualize the data and generate a correlation heat map for me, which is pretty cool. So we see over here, the heat map generation works, but we can see immediately that something is off because we are seeing a lot of white space, which means that some of the correlations are just not computed. But that's okay because the model has automatically understood the issue and flags it for me in the chat. And it seems that there are some date variables that should be used for correlation, and so we need to get that addressed. So it's running now to address those issues. And there, now we see a heat map that looks a lot better, more like what I'm used to seeing. And the agent not only produces this heat map, but what you're seeing come up here is that it's starting to draw conclusions for me, specifying where there are correlations in the data that I might want to use my own judgment to explore in further detail. And you can see these correlations over here in the notebook and also in the chat itself. And it's really helpful to see some of the insights from the heat map in addition to the actual heat map itself. All right, let's hop back over to the slides. So what you just saw was a fully integrated AI experience that puts a pair programmer inside your Colab workflow. We believe it's an ideal pair programming experience for data scientists. With what you just saw, the data scientists can now see the code and verify it. It's a really trustworthy source, can modify the code, tweak it, and run it again, and also easily export and share the notebook with coworkers. The code the AI writes is transparent, it's forkable, and it's shareable. We're also building the foundation to build more agents that can perform a very wide range of tasks, just like a pair programmer would in the real world. For example, we're exploring ways to minimize context switching and make the entire workflow more seamless. Imagine code transformations between languages or frameworks, or the holy grail, even an agent that handles breaking changes updates as you migrate your code base to the next available version of a certain language. We're so excited about how data scientists and developers will use agents in their workflow, and we're really looking forward to bringing these features to Colab in the coming months. Our big goal here is to keep you in the flow. So we're building agents that allow you to get back to coding and experimenting by offloading specific tasks that would otherwise get in the way. What I really love about what you saw today is that you can see the source code that's being generated by the AI as you're interfacing with it. You can try it out and know that it's correct. This intelligence, which is really woven throughout your workflow, is what helps developers and data scientists stay in the flow. And that's what matters the most when you're building, exploring, analyzing, or coding. Thanks so much for joining me to learn more about this work. And please follow Google Colab for the latest updates. Thanks for joining the Women in ML Symposium.